Welcome to the West Grove Primary School P5 Science Parents Workshop. I'm Mr. T, Head of Department Science. With us today are Madam Mindy Neo, Level Head Science, and Madam Nohuda, Senior Teacher Science. Today's workshop aims to help you understand the science curriculum and syllabus, and how science is taught in West Grove. We will be covering how you can play a role in supporting your child. There would also be some sample questions and strategies for answering these questions. Lastly, some tips on preparing for the exams. Learning of science in West Grove goes beyond presenting the facts. We adopt an investigative approach to teaching and learning, where students are provided with opportunities to investigate a problem, search for possible solutions, make observations, ask questions, test out ideas, and think creatively. Students are actively engaged in collecting and using evidence collected from outdoor classrooms through hands-on experiments, formulating and communicating explanations based on scientific knowledge. A wide variety of strategies are employed to facilitate teaching and learning of science. Lessons are planned and delivered in a way that would engage students in meaningful learning experiences and cultivate their interest and curiosity. Students become excited about learning and are motivated. The science curriculum seeks to nurture the student as an inquirer. The end goal is for students to enjoy science and value science as an important tool in helping them explore their natural and physical world. The aim of the primary science syllabus is to provide primary students with basic scientific terms and concepts, opportunities to develop skills, habits of mind, and attitudes necessary for scientific inquiry, prepare students towards using scientific knowledge and methods in making personal decisions. The syllabus also helps students appreciate how science influences people and the environment. This slide shows the overview of the primary science syllabus over the 4 years. Do note that cell systems, elastic spring force, and energy conversion are not required for students taking foundation science. Students are required to have an accurate understanding of the science concepts taught, make connections between these concepts, and apply them to new and unfamiliar situations. In some instances, they may be required to make a claim and support it with evidence.
To help your child think critically and apply science concepts they have learned, we would like to encourage parents to ask their children open-ended questions that focuses on solving problems using science concepts. For example, you may ask your child, "Why do we feel cooler after taking a shower?" Your child might respond, "After a shower, water gains heat from our bodies, and as it evaporates to become water vapor, heat gets taken away." Also, you may consider exploring together by providing opportunities for your child to practice problem-solving skills by playing games or working on projects together. Another way to help your child develop problem-solving skills is to create a positive learning environment. This means letting your child make mistakes, encouraging them to learn from them. "Hey, I'm glad you tried. Why do you think it didn't work?" Maybe you might say that. It's okay. Let's think of another way. Oh, I'm glad you did not give up. One way to encourage a growth mindset in your child is to praise them for the effort they put into studying and not just achievement. This encourages your child to focus on the learning rather than just the outcome. There are some open questions you could try asking them. For example, when facing the problem of opening a bottle of ketchup or chili, you might try asking them, what do you think we could do to open the bottle? Or why do you say so? How do you know? Hopefully, they can explain that when metal gains heat, it expands. So it allows you to open that bottle of ketchup or chili easily. You can even ask them, can you tell me more about expansion? Or give me examples of heat expansion? Another way is to explore science together with your child by watching science documentaries such as National Geographic or Discovery Channel, reading science magazines. There are a variety of options in the market, and even visiting places of interest such as nature parks, the science center, the zoo. There are so many possibilities, and I hope you can explore them with your child. To create a positive learning environment, try getting your child to solve everyday problems like drying clothes, as shown in the slide here. You may ask them which method will help the clothes to dry faster and why. Your child might explain that the clothes on the left have a bigger exposed surface area to the sun, so they are able to dry faster as the water in the shirts gain more heat from the sun and evaporate faster. So rather than giving them the answer, try asking questions that will lead them in understanding the science. Also, you may ask them, what other ways can we get the clothes to dry faster? They may come up with solutions like, we could put them in the dryer so that it will gain more heat. Well, if they're not sure, they give you a shrug, tell them not to give up and explore with them possible solutions. To create a positive learning environment, when we visit places of interest, such as Universal Studios, we might spot the globe with the sign Universal across it. Then we could ask our children questions such as, what do you think the white fumes are? What state do you think the white fumes are? And why do you think you feel cool when standing near the white fumes? Well, in answer to these questions, your child may say that the white fumes are made up of tiny water droplets, so they are actually in the liquid state. The warm water vapor in the surrounding air loses heat to the cooler air from below and condenses to form water droplets. So the white fumes are actually made up of tiny water droplets. When the droplets land on our skin, it gains heat and evaporates. So it takes the heat away from our bodies. When we see a roller coaster, we could also ask our children, why is the first drop in the roller coaster the highest point? And we could link this to energy conversion. The roller coaster is at the highest point so that it has the most amount of potential energy. Now, this potential energy gets converted to the most amount of kinetic energy. However, some of that kinetic energy is converted to heat and sound energy as it rolls down. So the roller coaster needs enough kinetic energy to roll up again to the same height or a higher height. Let's take a look at some samples of science questions that you and your child may explore together. Let's take a look at the first question. A worker used a truck to deliver blocks of ice. A mist was seen when the ice was taken out of the truck as shown below. Explain how the mist was formed. Now let's link the answer to the concept of condensation. You see, the warmer water vapor in the surrounding air comes into contact with the cooler air around the ice. It loses heat and condenses to form water droplets, which appears as mist. The second question states that the mist disappeared after some time. Explain why. So now let's link the answer to the concept of evaporation. So the mist that is made up of tiny water droplets gained heat from the warmer surrounding air and evaporated. For the third question, it states that the thick plastic strips were hung at the door to prevent the ice inside the truck from melting. Now we need to connect the answer to the concept of heat conductors. The thick plastic strips are poor conductors of heat, so they do not allow heat to flow easily into the truck. So the ice in the truck gains less heat and it prevents the ice inside from melting. Now this question wants us to consider the properties of a liquid. So which of the following about the packet of coffee is correct? Let's link the answer to the properties of a liquid. The coffee is liquid. It has no definite shape, but it has a definite volume, which means the amount of space it takes up is the same because the amount of coffee stays the same. So with this understanding of the properties of liquid, the answer has to be option 2. The shape of the coffee changed when it was put into a mug, but the volume did not change. This is another example of a real-life experience that you may have encountered before. An engineer wanted to test if an electric pot can be used on a table with a thick glass top. He heated water in the pot for 1 hour. Explain why part A of the glass top was hotter than part B. Now let's link our answer to our understanding of heat flow. Part A is actually nearer to the electric pot than part B. So heat travels from the electric pot to part A faster than to part B. Now, the second question states that the glass top cracked after some time. Explain why. Well, let's link our answer to the concept of expansion. Now, the reason why it cracked after some time is because the top part of the glass top received more heat and expanded faster than the bottom part of the glass top. So the uneven expansion caused the glass top to crack after some time.
In order to answer science multiple choice question, we first need to identify the relevant topic that the question is asking. By identifying the topic to the question, this helps the students to narrow down the related concept. The students can highlight, underline, circle keywords in the question to help them focus on the important parts of the question. This helps to develop a deeper understanding of the bigger picture. Elimination method is when you cross out all the answers that you know which are incorrect, and then focusing on the remaining answers. This strategy saves time and increases the chances of selecting the correct answer. Let us use the previous strategy in MCQ question. Let us try to understand the question first before answering. We have a ball that is tied to a string, then it was released. It swung and hit a plastic bottle. The bottle fell down. Let's identify the topic first. The question is testing us on upper block topic, which is energy conversion. Circle the phrase energy conversion in the question stem. Circle the phrase a ball is tied to a string was released. By linking the concept to the relevant topic, we learned that the ball possesses potential energy as it is released from the height. Based on that information, we proceed to eliminate the incorrect option, which is option 1 and option 3. Eliminating the incorrect option helps to shave off precious time. Moving on to the question, the phrase, it swung and hit the plastic bottle. This indicates that the ball moved and it has kinetic energy now. Therefore, the answer is option 2. Let's proceed on to open-ended question. There is a common weakness when it comes to answering open-ended question. First, the students do not understand the question. They need to break down the question and understand the question part by part. Next, the answers provided by the students are either incomplete or not specific. Students tend to include unnecessary information which is not required by the question. Marks allocation at the side of the question will give the students a gauge on how much they need to write. Lastly, students do not follow the instructions given in the question. Some questions may require the students to indicate their answers in a graph or diagram. Now, let's move on to an open-ended question. First, let's identify the topic. This question is testing us on both lower and upper block topic. The lower block topic is magnet, while the upper block topic is on electricity. Once we have identified the topic, we will start to brainstorm key words to guide our answers. Circle the phrase metal bar P move away from metal bar Y and touch the iron rod. When the circuit is closed, the iron rod will become an electromagnet. Since metal bar P touched the iron rod, which is now an electromagnet, it means that the metal bar P must be a magnetic material. This indicates there is a magnetic force of attraction between iron rod and metal bar P. Then we formulate our answer for question part A. A closed circuit is formed, causing the iron rod to become an electromagnet and attract metal bar P. Moving on to part B, circle the phrase, what happened to the bulb? Students are required to identify what happened to the bulb. Possible answers would be the bulb light up or the bulb did not light up. Students will then explain the reason for the bulb light up or not. Since metal bar P touched the iron rod, what happened to the circuit? Now, the circuit becomes an open circuit and electricity cannot flow through. Since electricity cannot flow through the circuit, the bulb cannot light up. So, how do we prepare for science examination? First, students need to revise topics from lower block and upper block. Usually, concepts covered in lower block are tested in a more challenging manner at the upper block. Asking questions can do more than measure what the students know. Asking appropriate, challenging, engaging, and effective questions encourage students to explore and refine their understanding of the key concept. During revision, do refer to the MOE science syllabus and also the recommended materials such as the textbook, science learning packages, the review exercises, and also the revision papers. Learning happens when a student has a good understanding of concept taught and good transfer skill. They have the ability to apply the knowledge to solve different types of problems in different contexts. What is more important is to understand the big idea behind the concept and practice applying it in various situations. The forgetting curve theory explains how our memory works. there is a need to spend time understanding the materials. Students need to pay attention in class. Do encourage your child to clarify doubts with his or her science teacher. When science homework is given, do remind your child to put in effort in understanding their homework assignments. Cramming doesn't work. The forgetting curve is at the steepest earlier on. This indicates that everything you cram in a day before the test may slip out of your head like sand through your fingers. To excel in science, the students need to put in time, effort, and their revision must be regular too. Teachers deploy various strategies to help the students. Use the strategies during classwork and homework regularly. This helps the students in analyzing the questions, interpreting the data, and apply the concept they have learned. Note-taking plays a crucial role in the students' academic performance. It highlights the key ideas of the topic in a logical way. The act of recording and organizing information helps students reinforce in their understanding and retention of science concepts. Students can rely on these notes to review and revise the content covered in class. Note-taking also allows science students to actively engage with the material, enhancing their understanding of science concept. The act of writing notes helps the students to better retain scientific knowledge. Students can use mind map to help them to visualize and streamline complex information. They can also use the mind map to help them to revise. Mind map helps students to summarize, link key concepts learned, and make sense of what he or she has learned. This will give a student a strong foundation in the learning of science so that she can pick the right concept and apply them in answering science questions. Mnemonics are memory devices that help students to recall larger pieces of information, especially in the form of lists like characteristics, steps, stages, or parts. Students can use memory devices in learning new vocab words and facts. It can be easier when students connect the new information with something that they're already familiar with. To end off, it is important for students to know the concept, apply the big ideas to the new situations, support their choices with evidence, and make an effort to revise regularly. Thank you.